integration piece, right? So you can have a formula sheet for the quiz next Thursday. Of course, you can have a formula sheet for the second midterm and a formula sheet for the final. 1 page, front and back. That's it, right? All right, so our next U sub is let U be the downstairs, okay? Let U be the entire downstairs, okay? What's it?
What's the Thursday schedule?
Integration.
Oh,
Right now, I'm thinking area under the curve or steps 1 through 6 here. Because we're done with those today. You'll be able to ask about it Tuesday. You'll be able to answer questions on Thursday. Okay? And don't hate me if I decide just not to give a quiz because I'm really burnt out, just like you are. I don't feel like grading anything. Right? Oh, I recorded that. Sorry. All right. Let U be the downstairs completely. Right? So, for example, and I have to remind us about the antiderivative of 1 over U. Right? It's ln of the absolute value of U. Right? What? So, on these, when we let U be the downstairs, we're going to need the absolute value sometimes, right? So here we go. I'm going to do the integral of x over 1 plus x squared dx. Now these are fun to do. Think about 1 over 1 plus x squared, x over 1 plus x squared over 1 plus x squared, x cubed over, that one we can't do yet. So the last one is Calc 2. But this one we can do, okay? Now, it kind of looks like arctan, right? I'm looking for derivatives of arctan and arcsine whenever I can, okay? But it's not. So, not a real clear inside here. Where could you guess there's an inside? Okay, but downstairs is the whole downstairs. And I do agree with you, it is kind of inside because you think of fractions as a wrapped numerator and a wrapped denominator. So you are inside, right? But there's another inside downstairs. Where's the other inside? Yeah, the square. So x, what I'm putting in for x is the inside. But of course, if I let U be x, du is dx, and this just simply becomes U over 1 plus U squared du, and it's the same problem. Okay, so like I said, you can try something, right? Do you agree with that, first of all? If U is x, right? So there's the inside. If U is x, well, the upstairs is now U, the downstairs is now 1 plus U squared, and du is dx. So dx is now du. So it's the same problem. So that's not it. So we're going to our next level inside. It's got to be the whole downstairs, right? Let U be the downstairs, 1 plus x squared. And what do I get for du? 2x dx. Everybody okay there? Do I have 2x dx? No, but I want it. Can I make it happen? Yes. I have to multiply by 2 and divide by 2. Yep. Multiply by 2, divide by 2. So 1/2 of the integral. Now upstairs is just du. I have 1 over 1 plus, 1 over u du, right? And that's 1/2 of the ln of the absolute value of u all plus c. Is everybody with me? What is u? The downstairs, 1 plus x squared, right? So I have 1/2 of the ln of 1 plus x squared all plus c. Why don't I need this absolute value? It can't be negative. 1 plus x squared is a quadratic above the x-axis. Can't be negative. So I could even go further and say this is the ln of the square root of 1 plus x squared all plus c. How do we double check it? Derivative, right? So y equals the ln of the square root of 1 plus x squared. And I am supposed to do the derivative. Let's not forget, if y equals ln of u, y prime is 1 over u prime, or u prime over u. Right? Make sure this is on your formula sheet. We didn't have it happen in our first midterm, but it will happen in the second midterm. So you make sure you know how to do it. So how do I do this derivative? What's the inside? Square root of 1 plus x squared. And then I need the derivative of that. I need the derivative of the inside. Oh, that's a prime. So what do I get? What's my derivative there? 1 over 2 square roots of 1 plus x squared times another derivative of the inside. Yep. Yep. Yes. So that's the formula that we have memorized, and it's on your formula sheet, and it's on your cheat sheet, right? All right. So what happens here? Oh, yes. I'm sorry. I got lost. So now I have a 2x over 2 times square root of 1 plus x squared times another square root of 1 plus x squared. And yes, the 2 cancels, and what happened to the roots? They cancel, right? I'm squaring. They've got the same thing in product twice, so it's squared. There it is, and that's the same, right? That's the same original problem I started with. On the back page of the review, do you see anything that has a potential of letting u be the inside? Well, I just did 22. I'm sorry, letting u be the downstairs. Do you see anything that has the potential of letting u be the downstairs? I think I'm thinking 30 and 31. 34 is not. That's a good one to do, though. Let's do 34 first. It's not a u downstairs, but it's a good one to do because it's tricky. This is 34 on that packet. So the integral of x over 1 plus x to the 4th dx. So look, my gut might be try u as the downstairs, right? And that was Yvonne's gut feeling there, right? But what's du here? 4x cubed dx. The problem is I can get the 4 in there, but why can't I multiply by x squared? I can't, well, right, I can't divide by a variable, and I would have to put the variable that I'm dividing by outside of the integral, but it's dependent upon x. I cannot remove something that's dependent, right, on the integration itself, right? You see what I'm saying? Like someone might say, well, let me multiply by 4x squared and divide by 4x squared, right? I mean, it seems reasonable, right? But I've pulled an x out of the integration. I'm not allowed to. Right? Because it's dependent, this operator is dependent upon x's. So it must be something I missed. It must be one of my methods that I missed. I tried that one, it didn't work. I don't have anything else yet. Right? So it must be something I missed. And we had just done it. I said that there is an inside here. Right? Yes. du is 4x cubed. In order for me to get a 4x cubed out of this, I need to multiply by 4x squared and cancel it with a 1 over 4x squared. But I'm not allowed to move an x in and out of an integration. I can move constants in and out. I can move the coefficients in and out, right? I cannot move variables out. So it turns out that the inside is, I want to see it as an arctan. So what do I want to put in that arctan piece? X squared. So that means, so this failed, right? So that means u is x squared. And what is du? 2x dx. There it is. I need the 2. I need to cancel it. This one's going to work. So now I have 1/2 of the integral of 1 over 1 plus u squared du. So it's 1/2 of the arctan of u. And arctan is x squared. Sorry, u is x squared. So, by the way, I didn't get to my arctan methods yet, okay? But obviously, you're going to recognize this. You're going to look on your list of derivatives to see anything that looks like that, right? And you're going to make it happen, right? You're going to then know it's an arctan. My arctan methods are coming up here. Right, my arctan, so we're on 7. We're on downstairs, and then we're going to do all the anti-inverse trig ones. So again, on the back of that exam, final exam review, midterm 2 review, it looks like 31 will work. 31 will be a hole downstairs, so let's do that one. Are we ready? Yeah? So the integral of sine of 2x. Now this one's tricky because I see a couple of insides, right? I see a 2x that's inside. I'm sorry, go back. Yep. All right. Yes? You okay? So I see an inside of 2x. I see an inside of cosine. right? So it'll be pretty obviously it's not u is 2x, right? Why not? What's du? 2dx. Now I can make that happen, but what the hell do I do with everything else? Right? So it's not that. I can let u be cosine, and I'm thinking it's an inverse trig now, right? 1 plus u squared downstairs, right? But what's du? Negative sine x dx. I don't know how to get a 2 inside of that. I can't. Right? I could get the negative, right? But I can't get the 2 inside of the argument of sine. There's no way to do that. Right? You agree with me, right? So that fails. And it's okay, and I'm telling you, when I first learned this stuff, there's plenty of times when what I tried failed, and it's good to fail, right? I always say the reason why I get along with my current girlfriend is because I have an ex-wife. It's good to fail. You learn when you fail. So you try things, and if they fail, so what? Try something else. What are you going to do? Quit? No. Fight. So we're gonna try the u as everything downstairs. Help me with my derivative. Well, derivative of 1 is gone, right? So I get, good, 2 times cos of x now to the first power instead of second power times another negative sine x, right? The inside was cos x. I need to do chain rule. So dx, right? So I get here negative 2 sine x cos x dx. And I recognize, because my pre-cal teacher tortured me with it, that this is a trig identity, right, of negative sine 2x. Right? Did you have pre-cal teachers that tortured you with trig identities? You should have. If you didn't have a pre-cal teacher that tortured you with trig identities, you should demand your money back. Sue the school. You did not prepare me for calculus. It'll be a big scene. I'll be fired because I suggested it. I'm behind it, right? But it'll make the news for sure. You're going to sue Montgomery College for your tuition back because the teacher did not prepare you? I love it. Or sue the school because they allowed me to cheat on the placement test that put me into a class I wasn't prepared for. I should get my money back. Let's do it. We'll make a big statement, be on the news, change the world. We will change the world. All right, let's shut up now. All right, what do I have now? So I have the integral. Well, upstairs, I need a negative, right? So I need to multiply by a negative twice, yes? So now I have a negative integral of 1 over u du. Nice. Right? Downstairs is u. Upstairs, I made it happen. Negative sine 2x dx is my du. Is everybody okay here? So I get negative ln of the absolute value of u plus c and I recognize that u is 1 plus cos squared x, right? Do I need my absolute value there? No. Cos is right. Now, either anywhere from 0 to 1, not from negative 1 to 1, right? Because I put the absolute value on it. So I don't need that absolute value. I like c minus the ln of 1 plus cos squared x. How many points are you going to take off if I don't take off the absolute value? 1. It's interesting to kind of write this also as the ln of 1 over 1 plus cos squared x plus c, but I don't save strokes, right? Do you agree how I can do that? You should have had a pre-cal teacher that tortured you with the properties of logs. And if they didn't, let's sue them. Let's get our money back and sue them. Sue the school. You did not properly teach me pre-calculus. I'm a little angry. Sorry. Do you agree? The negative is actually the exponent. The negative coefficient is the exponent on the argument. And -1 exponent means reciprocal, right? But it doesn't save me strokes, so what? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm trying to save strokes. I'm trying to save computer memory. I'm trying to write my code in the least number of characters as I can. I'm trying to say as much as possible with the least amount of speaking. Nice. You notice 32 is not the downstairs, right? Do you see it? Do you see 32 is arctan yet? 1 plus u squared, right? And if u is cosine, derivative of cosine is negative sine. So I almost have my negative sine dx there. 30 is the downstairs, right? 30 is the downstairs. U is the downstairs. What's the derivative of that downstairs? Just e to the x, and that's what I have upstairs, right? So good problems there to do. All right, let's move on to our arctan piece. This is it. This is our last real lesson. One final lesson. This is it. This is the end of it. Our last method of integration is using inverse trigs. So you got to look for them. You got to know what your inverse trig derivatives look like, because you're looking for those to show up in an integration, right? So the integral of x plus 1 over 4 plus x squared. So one of my early methods is long division. Can I do long division here? I don't do long division unless I have a power upstairs equal to or greater than my power downstairs. So long division is out. But in that same step is divide and conquer. So I see I can divide and conquer here. I think that's the way I want to go. So I've got the integral of x over 4 plus x squared dx plus the integral of 1 over 4 plus x squared dx. So what are we talking about here? Integration method, inverse trigs, right? And these are probably the toughest part. So, toughest part, do you think it will show up on your test? Yes. I always like to test you on the most difficult things, because then I know you're ready. Who wants an easy test? What is it? You don't walk out of here feeling such pride that you just took the most difficult test you ever had in your life and you did well. That's how you want, that's what you should be feeling. Of course, until you take Calc 2, then you'll take the most difficult test you ever took in your life. But you're learning, you're intelligent, you're discovering things that a vast amount of people will never know. It's awesome. Well, it looks like I have two types of integration methods to do here now. The left one, what process would you do? U is the downstairs, right? Because you could see the derivative of the downstairs is 2x dx, right? So you know you're going to do a 1/2 and a 2 here. What's the other one look like? What's well, if I let u be the downstairs, I need a 2x dx. Can't happen, right? It's arctan. But I have to remember, right? I know if y equals arctan of x, on my formula sheet, I got y prime is 1 over 1 plus x squared dx. That's it, sorry. I'm doing the wrong thing. 1 over 1 plus. So what don't I like there? And that's the 4 I don't like. So I'm going to factor that 4 out. I'm going to factor out that 4. And so I'm going to divide each of those pieces by 4. So 1/2 of the integral of 2 over 4 plus x squared dx plus 1/4 of the integral of 1 over 1 plus x squared over 4 all dx. Okay, still, it looks like arctan, but now I don't like what I'm seeing. I don't like the inside anymore. So what am I going to have to do there? I'm going to let x, right? Let u be x over 2. And now what's du? Uh-oh. It's having a hard time, just like you are, understanding what the hell happened. The program just quit on me. It says, this is too difficult. Yes, Ian. I didn't do it yet. On the first one? The first one's going to be, the downstairs is going to be u. But you can see I'm going to have an alphabet problem in a second. I'm going to have a u sub for one thing and a u sub for the other. Danger, right? So I'll show you what I'm going to do, though. So I'm going to let u on the second integral be x over 2, right? And I can see that u squared is x squared over 4. Okay, nice. I need du. That's 1/2 dx. So I need a 1/2 here and a 1/2 here and a 2 here, right? Over here, I'll do a w. I'll let w be the downstairs, right? And so dw is 2x dx. So I have 1/2 times the integral of 1 over w dw plus 1/2 of the integral of 1 over 1 plus u squared du. Nice, I'm back to the step 1. I'm back to step 1. I recognize both these derivatives, right? I recognize 1 over w and I recognize 1 over 1 plus u squared. So what do I get? Half of the ln of the absolute value of 4 plus x squared plus half of the arctan of x over 2 plus c. And of course you can notice that I don't need my absolute value, right? So I've got the ln of the square root of 4 plus x squared plus 1/2 of the arctan of x over 2 plus c. most of the time, we will not be, Grace, give me 1 second, we will not be converting multi-fractions into a single fraction when we integrate. Grace, question. For the second one, what happened to the... from here to here, are you saying? Yeah, they just reduce 2 over 4. Yeah. So, arctan levels, let's think about them. Or arc sine, won't give you arc cosine, right? The only difference there anyway is in the negative out front. So what could happen? Ian, question. Up a little bit? Yep. Yep. So what could happen? I could just see the inverse trig. I could have to manipulate the inverse trig with some arithmetic, right? I could have to divide and conquer. What else could happen? My favorite one of all, I have to complete the square. You remember the good times you had in pre-cal when they made you complete the square over and over and over to write things in vertex form? Do you remember that? Brian is shaking his head because I tortured Brian with that in pre-cal. Remember our translations of the quadratic? How we turned it into a vertex form and we could just see it shifted up and over, right? If your pre-cal teacher did not torture you with completing the square, we should put a lawsuit together, go public with it, sue them for our tuition back, and the pain and suffering. How much do you think you could get for the pain and suffering that you're going through now because your pre-cal teacher didn't teach you how to complete the square? I think we got a case. I'm not joking. I think we have a case. I think we'll be famous. Now, I got to take a cut because I'm going to get fired and I'm never going to get another job anywhere. Right? So I got to take a cut. You think you have pain and suffering. You should imagine what I'm going through when you can't complete the square. I'm like, how the heck can't this student complete the square? And now we know. We're going to blame it on the pre-cal teacher. And we're going to sue. We're going to get our money back, plus pain and suffering. I'm talking millions and billions of dollars. Oh my God, what's wrong with me today? Here we go. And it's all on audio tape. I'm sure I would even get fired now, even before the lawsuit. Well, oh my God. This is horrible looking, isn't it? Wait till you see how bad this one is. And this one, something like this on every test I ever give. And you're about going, I'm going to sue you, Robert, for pain and suffering. So what's your first instinct? You is downstairs. Yeah, that's the first thing I would see. Because when I get du, it's 2x plus 4, right? Okay. So can I get the 2x to happen? Can I get the 2x to happen? Can I get the 2x to happen? Yes. So I'm going to get the 2x to happen. Can I add 4 upstairs? Yes. As long as I also subtract 4. There's my add 0 that I was talking about Tuesday. Multiply by 1, add 0. Divide and conquer now, right? Do you see it? So I have 1/2 of the integral of 2x plus 4 over x squared plus 4x plus 8 dx minus 4/2 of the integral of 1 over x squared plus 4x plus 8. Make du happen with arithmetic only, no variables, right? So I can multiply by 1, I can add 0. Oh, wait. Well, the first integral's done, isn't it? It's a 1 over u, right? So the first one's done. This is 1/2 of the ln of the absolute value of x squared plus 4x plus 8.
How do you get rid of the minus?
It's right here.
Oh.
Yep. Yep. And so that becomes what? Negative. That becomes -2, right? Well, I'm interested in that polynomial there. I'm interested in that polynomial because, well, one, it's going to tell me something about the absolute value if it's needed or not. So I'm interested in that polynomial. I want to take a look at it, right? So I'm going to Desmos just because I can. And I want to look at that polynomial and see if it can be negative, right? Y equals, what was it, x squared plus 4x plus 8? Nice. Oops, equals 8. Silly Robert. No, can't be negative. Which I also mean, that means I know it has no roots, right? Yes? Okay. It's giving me the hint that I need to complete the square downstairs. Okay? And you say to me, well, how the hell am I supposed to know this? No, I'm teaching you what to do. We've been going down these processes that will stop working or not work, and we need something else. We need something else. In Calc 2, we have 12 more methods. Okay, first thing we do all of these over and then do 12 more. And then they fail. And we turn things into series, like we did with the Riemann sums. That's the hard part in Calc 2. So I see I don't need this absolute value. So I want to complete the square here, right? And turn this into a 1 plus u squared somehow. So this piece right now is that's what I'm going for, okay? So I've tried everything else. The last thing I'm going to have to try is complete the square. Don't know if it's going to work yet. It will, but I'm thinking, I'm not sure yet, right? That's a question mark. So I've got x squared plus 4x plus 8. And I'm going to group my first two terms, my leading terms there, and leave out the 8. And I notice I want to make sure I get my leading coefficient to be 1. Okay? And now I'm finding k. Once my leading coefficient of x squared is 1, I'm going to now look at the coefficient of x. And it's what number? 4. I'm going to take half of it, 2. I'm going to square it to get 4 again. I'm going to add the 4 inside and subtract the 4 outside. I'm going to add 4 inside, subtract 4 outside. What I have just done is created a perfect square. So now my parenthesis, that quadratic, is factorable. So what do I get there? I get an x plus 2 quantity squared plus 4. So you could kind of see, you could almost see my 1 plus u squared. But I have a 4 plus u squared. You with me? So I've got the ln of the square root of x squared plus 4x plus 8 minus 2 times the integral of 1 over 4 plus x plus 2 quantity squared dx. What don't I like there? There's two things I don't like there. Oh, I also don't like the whole problem. I don't like the teacher. You know, there's lots of things, right? But what don't I like there for the arctan? I don't like the 4, and I don't like the x plus 2. I'm going to have to get rid of the 4. I'm going to have to do a u sub. So I'm going to divide everything by 4, right? Or factor out the 4 here. That's the easiest way to think of it. So I have the ln, that's a mistake, square root of x squared plus 4x plus 8. I typically will split this into two problems so I don't have to keep writing this ln piece over. I'll say, okay, I'm only working on this one now. And then at the end, I'll put them together, right? So I've got minus 1/2 of the integral of 1 over 1 plus x plus 2 all over 2 quantity squared. Do you agree with that? We agree there. Anybody else? Now I need a u sub, right? So u is going to be x plus 2 over 2. And of course, du is 1/2 dx. Nice, I have a 1/2 dx. Ha ha! I have a 1/2 dx. Right? My 1/2 dx became my du. Oh my God, right? Why are you so evil, Robert? That's what you could be thinking right now. So ln of the square root of x squared plus 4x plus 8 minus the arctan of u, which happens to be x plus 2 all over 2, all plus c. There's some nice ones in this packet, okay? There's a couple in this packet for you to do.